Dear students, greetings from Dr. T. Sendil Murugan, Associate Professor and Head Department of Information Technology, Kakatiya Institute of Technology and Science, Varangal. In this video lecture, we are going to discuss about queue data structure. In previous video lectures, we are discussed about what is stack and applications of stacks we are discussed. In this video lecture, we are going to discuss about queue data structure. What is queue? How we can perform the linear queue, what are the operations on queue, and how to implement the queue using array. So these are the topics we are going to discuss in this video lecture. Dear students, this is week 6 lecture 2. We have to discuss about queue CDT-17, queue introduction as well as array representation. The array representation of queue is CDT-18 topic. Both the topic we will cover in this video lecture. So before starting our lecture, we must know about outcome of this lecture. What is outcome of this lecture? After completion of this lecture, student will be able to develop a C program to demonstrate the queue data structure with its operations using array. So what is queue? So before starting the data structure queue, we must know that queue wherever we are using the queue. Example, people moving on an escalator. So who is step first, he will reach out in the top floor. Okay. So like that, people waiting for a bus, if they are standing in the queue, who is coming? The first person standing in the line will be the first one to the get into the bus. So same like that, wherever we are following the queue. For example, in a ration shop or in somewhere, we want to follow the queue mean. For example, voting booth, you will stand for give vote for the elections. There also we are following the queues. So example, luggage kept on the convey or belt. What happened? Which bag which was placed first, that will be come out first. Okay. For example, car lined at a toll bridge. What happened? So who is coming first? He will go out first. Okay. So these are the some examples of queue. Okay. So same concept we will implement in the data structure also as a queue concept. Okay. So in the previous example, so what we seen that the elements at the first position is served first. Okay. So same is the case with queue data structure. The queue data structure is following F5 F4 order. So first in, first out order. So previously stack we are discussed last in, first out order, LIFO order. Okay, for stack. But here queue is using FIFO order, first in, first out order. So what is first in, first out? Who is come first? That will go first. Okay. So example escalator, bus, queue. So like that we seen no the previous example same. The elements in a queue are added at one end called the rear. So whenever we want to add any element in the queue, that will be added in the rear position. Okay. So if you want to remove any element in the queue, we have to use the one end is called like front end. Okay. So for example, in data structure, this is the array. We will take this array. Okay. So this is the queue. If example, this is the following queue. What happened? So in this array, we can insert the element here only. Okay. So this is the rear position. This is the front position. Okay. So initially we have to insert in rear position. So initially what is that rear also pointing in the first location. Okay. So rear, it will be add the rear pointer will move forward this direction. Okay. So if you want to remove any element means we can remove from this direction. Okay, this is first in first out order. So the queue we can implement using both array and linked list. But in this lecture, we are going to discuss about array representation of queue. So before starting the operations, we must be know all the operations on queue. So first one is NQ operation. So normally we know that array operation, that is insert operation is there, no? So insert we can say in the queue is NQ. Okay. So whenever we insert the element into the queue, we can say that the operation is NQ. The remove of the element from the queue is DQ. So that is delete operation. Okay. So delete operation will represent that DQ. So peak operation or friend function, these two are represent the topmost element of the. So top is pointer we are discussed in the stack, but here we are using two pointer. One is friend and another one is the rear. So peak operation will reflect friend operation. Rear position means the operation returns element at the rear end without removing it. Okay, it not remove or delete, but just return the values. So what are the condition we are checking? We have to check the queue is full or not and queue is empty or not. So when we have to check if full means we are unable to NQ. If it is empty means we are unable to DQ operation. So finally size of the operation it will return total number of elements it contains. Okay. So these are the basic operations on the queue. It's look like similar, but we have two pointer we are using here, front pointer and rear pointer. Okay. So as stated earlier, queue has front and rear variables that points to the position from where deletion and insertion can be done respectively. Okay. So this is the front position. So this is the rear position. Okay. So what is the size of the array? The size is 10. Okay. So we can say that it is the maximum value is 10. So max minus 1 is 9. Array will be represented using 0, 10, minus 1. That is index value. Okay. So if we want to insert any element means where we have to insert, we can insert at the rear position. Okay. After 36, that next position we can insert. If you want to insert 45, that should be in the sixth position. Why? Because the rear position only we are adding the value. So after adding the value, we have to write rear plus equal to 1 or rear plus plus we can write. Okay. We want to remove the element means we can remove from the front position. Okay. So we can remove from the front position. So if after deleting the element, it's look like this. The queue is look like this. We are remove the first element 12. So the remaining values are there. So what happened? Front value will be plus plus. Okay, front is initially 0. It will point into front plus plus. Okay. So whenever we are inserting the element, rear plus plus. Whenever we are deleting the element, front plus plus. Okay. So in the figure 1, initially front equal to 0, rear equal to 5. The position they are saying. If we want to insert the 45 element, what we have to do? We have to increment by 1. So 5 should be 6. In the sixth position, we can assign the values. The rear is pointing to 6. Simply we can assign the value into the 6. If you want to delete an element in the queue, what we have to do? We have to delete from the front position. So this is a simple algorithm. So if you want to NQ operation, what we have to check? We have to check rear equal to maximum minus 1. So that means the entire queue is full. The entire array is full. Then we can print that overflow. Otherwise, what we have to do? We have to, after printing it, it will come out. So otherwise, we have to check front equal to minus 1 and rear equal to minus 1. Both it is pointing to the minus 1 means it is initially set to front equal to rear equal to 0. Then we can else we can set 0. Then after that else rear equal to rear plus 1. Okay. So that we have to check. Why? Because in the rear portion only we are inserting the element. So rear value we can set it into the 1. Okay. So next set q. of rear equal to number. Whatever number we are given, simply it will add it into the rear portion of the queue. Okay, this is a simple algorithm for insert element. For remove the element, what we have to check? We have to check it is empty or not. If it is empty means we are not able to perform the operation. So what we have to check? Rear is maximum minus 1 means that queue is full. Okay. If otherwise, it will be the, you have to check underflow condition. What is underflow condition? That is front equal to minus 1 as well as rear equal to minus 1. The initial condition, both it is pointing to the first location, there is no value. If there is no element means we are unable to dequeue the operation. So simply we can write, we have to check it is overflow or not. If not, queue is empty, we have to check. If it is empty, we are unable to delete. It simply we will write underflow. Otherwise, we can write rear minus minus, not rear minus minus, front plus plus. Okay. So what happened? Why we are using front plus plus? Front plus plus means the front side element will be removed. Okay. The value is stored in the queue is the location printed in the rear. So what we have to check? We have to check front equal to minus 1 or front equal to greater than rear value. If it is there, it is underflow. Okay. So then what we have to do? If it is not there means simply front equal to front plus 1. This is delete operation. Okay. So these two conditions we have to use for delete operation. So now we will discuss about the program. So what are the operations are there? Insert the element and delete the element. So this is, we can say NQ, this one DQ operations. Peak operation will return front function value where it is finding it, and display means the entire value, entire queue it will be displayed. What it is there, what are the values are there, that will be displayed. So now we will give the options menu that if you are press 1, it will insert the element. If you are pressing 2, delete the element. If you are pressing 3, peak element. If you are pressing 4, it will display. 5 means exit. So after getting the option, it will check. Accordingly, the option will be there. If first option means simply we are calling the insert function. If pressing 2 means which we are calling the delete element function. After deleting, that value will be returned here. If the values are minus 1, simply we can print the number deleted. Okay. Then if the given value is 3 means it is calling the peak function. It will return the value which is pointing to the queue. Okay. So this is the main function. After getting that, we have to insert element. For insert, what we have to check initially, which element we want to insert, that we will take it. Okay. So after taking this value, we have to check rear value equal to max minus 1. Why? Because rear is the one point to add the element into the queue. If it is max minus 1 means the queue is full. Okay. So you can write overflow. Otherwise, what we have to do, we can change that. We have to check minus 1 or rear also minus 1. If it is rear 1, we have to change it to the 0. Why? Because first value we have to add it. Otherwise, rear plus plus. We change the position. Okay, so this is the queue. First, we have to check rear position because rear only we are checking. If rear is pointing to maximum minus 1, we can say it is overflow. If not, we have to check it is no values in the array queue or not. If both are pointing here means minus 1. Okay, so both are representing minus 1 means no element in the queue. That is the first element. Then rear value we can change it to 0, the first location. Okay, so if this condition also is not, it is not overflow, it is not empty. Then we have to, somewhere it is pointing means, then rear value we can write it is rear equal to rear plus 1. Okay, so that is rear plus plus. So after changing the pointer, simply in the queue of rear position, we can add the value, which value we are getting it from the user. Okay. So delete element. Delete element, what we have to check? So front equal to minus 1. So if any elements are there, the front position is pointing to the front location. Okay. And the front location equal to minus 1 means no element into the queue. Our rear value is greater than front value. Okay. So rear pointer is pointing it. So front pointer we are deleting here. Okay, it will move here. When we are deleting, front pointer is moving forward direction. When we are removing, the rear position will be -1. What we have to check? If it is not crossed this value, okay. The example we are deleted. So rear pointer is pointing to here only. If both it is greater than that value, we are unable to do that. Both conditions are under flow. Otherwise, we can remove the topmost element, front element of the queue that will be assigned to value, because this value we are returning to that function. After that, front pointer is pointing to next location. Then we have to check front is greater than rear means simply we can print -1. Otherwise, return the original value. So now peak operation, you know that return the queue of front position where it is pointing to that. So display functions, it will start from the front pointer to rear pointer. Okay. So simply we can print the entire queue. So this is the main. After choosing the operation, it will perform. It will ask the value. It will be inserted like that. It will show. You can call one by one. You can check the test cases. So types of the queues. The queue have multiple types like the circular queue, D queue, priority queue, multiple queue. So these topics we will discuss in the further videos. Okay. So now we have discussed what is queue, what are the operations on queue, how we can implement the queue. So using queue concept like programs also we discussed. Okay. So array representation of the queue we are used for that front and rear pointer we discussed. What are the condition we have to check? Overflow and underflow. Those things we are checked, and with that we are implemented the NQ and DQ with the algorithm. After that, we are written the program and explain step-by-step explanation for the operations on queue. Okay. So now we are end of this lecture. So after discussion of those topics, so you know that you have to do this lecture level practice problem. So the following operation with the help of queue and draw the queue after each operation with the front and rear pointer. So what we have to do first, initially you can calculate what are the operations are there. So initially insert operation, 1, 2, 3, 4 elements we are insert. After that is full or not you are checking. If it is full means it will print stack is, queue is full, or otherwise overflow you can check. Or after that you have to perform DQ operations 2 times. Then you can call the peak operation, what is the front pointer is pointing it. Then DQ operation 2 times. Then you can check it is empty or not. If it is empty, you can print empty or underflow. Then you can finally print the size of the queue. Okay, so this operation we can perform. So I hope you are enjoyed this entire video, dear students. Having completed the discussion on introduction on queue and array representation of queue, now students should be able to develop a C program to demonstrate the queue data structure with its operation using array. Okay. So if you have any doubt, please refer the chapter number 8.2 in Rima Tareja textbook, array representation of queues. If you have further doubt, you just visit the weekly tutorial sheet as well as come with the doubt we will discuss in the classroom discussion. Thank you very much for listening. Thank you all.